Figure 9.2, Inheritance Hierarchy for University Community Members. We use the diagram that you see here to introduce some of the key terminology that we'll be discussing over this lesson and the next lesson as well, and also some of the key concepts that are important for pretty much any Java program that you'll ever write. So in this diagram, what we have is a UML class diagram. The Unified Modeling Language is kind of a standard graphical modeling language for helping you design systems, and the UML class diagrams are often used among their many different uses to show you the relationships between classes in a class hierarchy. So what you're looking at is a hierarchy diagram in which we have what we call superclasses and subclasses. At the top of the diagram is the superclass called community member, which might be used to represent all of the common aspects of the people that are part of a university community. So things like every university community member would have a first name, a last name, perhaps a social security number or ID number of some sort. And as you've seen in building other classes in Java, when you have data in a given class, you typically also have functionality that enables users of that class or the client code of that class to interact with and sometimes modify the data inside an object of the class. So all of that would be defined in the so-called superclass of the hierarchy, and that way all of the classes below that class in the hierarchy can quote-unquote inherit those capabilities in a similar way to how you inherit aspects of your parents, such as perhaps your eye color or physical attributes, etc. Below the community member class in this hierarchy, we have many other classes, but specifically in this first row, we have these subclasses called employee, student, and alumnus. And the key relationship that we get when we use inheritance is that we can now say that an employee is a community member, a student is a community member, and an alumnus is a community member. And this arrow with the hollow arrowhead is the UML notation that represents the concept of inheritance, where one class inherits data and functionality from an existing class. And that is one form of software reuse in Java. Another form that we've been using so far is to have existing classes from which we create objects and then use those objects in our programs. And we talked a little bit in a prior lesson about the concept of composition. With inheritance, the form of reuse that we use is to bring in existing capabilities of an existing class and then build upon those capabilities. Now, continuing in this diagram, below employee we have faculty and staff. So faculty and staff are subclasses of employee, but they're also indirect subclasses of community member. So we can say that a faculty member is an employee, and because a faculty member is an employee, we can also say a faculty member is a community member. Similarly, a staff member is an employee and therefore is also a community member. So what we have here are not only superclasses and subclasses, but also what we might call direct superclasses and direct subclasses. So employee is a direct subclass of community member, and community member is the direct superclass of employee. Faculty is a direct subclass of employee, but it's also an indirect subclass of community member, meaning that we have to go up one or more levels to get back to community member, and therefore community member is also an indirect superclass of faculty. And finally, at the bottom of the hierarchy here, we have administrators and teachers. An administrator is a faculty member and is therefore also an employee and is therefore also a community member. A teacher is also a faculty member and is therefore also an employee and is therefore also a community member. So the is-a relationship is the inheritance relationship, and that's what we'll be focusing on primarily here in this lesson. Figure 9.3, Inheritance Hierarchy for Shapes. Similar to the community member hierarchy that we just looked at, this shape hierarchy has a superclass at the top of the hierarchy, in this case called shape, and it has many different subclasses of shape. On the left side here we have the category called two-dimensional shape, and in this particular hierarchy the shape class would contain anything that's common to all shapes. For example, we might say that all shapes have color, and then separately the two-dimensional shape class would represent the subset of shapes, the subclass if you will, that contains just the two-dimensional shapes, and anything that would be special to all two-dimensional shapes would be defined in this level of the hierarchy. Below two-dimensional shape we have three different types of two-dimensional shapes shown here: circles, squares, and triangles. And again, the way the is-a relationship works, circles can be considered to be two-dimensional shapes. A circle is a two-dimensional shape and is therefore also a shape. A square is a two-dimensional shape and therefore also a shape. A triangle is a two-dimensional shape and therefore also a shape. On the right side of the hierarchy we have a set of subclasses specific to three-dimensional shapes, and anything that is common to all three-dimensional shapes would be defined in the class called three-dimensional shape. And below that in the hierarchy we have spheres, cubes, and tetrahedrons. So each of these has the is-a relationship with three-dimensional shape, and in turn each of them can also be considered to be shapes based on this hierarchy. Now, the one thing that we're not talking about so far is the fact that there is actually one class hierarchy in all of Java. So at the top of any class hierarchy diagram like this one or the community member one, there is actually a class from the java.lang package. It's called object, and every single class we ever create is either directly or indirectly a subclass of class object. And what that means is that all of the classes that we build have some common methods in particular that come from class object, and we'll give you an overview of those as part of the first code example.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than Live Lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live Lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.